Hey everyone, welcome. My name is Peter. Today we're going to talk about getting started with policy as code. And so a little bit about me. I work for a company called Styra. I do DevRel for them in the US. We have an open source project called Open Policy Agent, which is the premise of this talk. It's not just us anymore, but I'll get more into like where that project is kind of sitting in the ecosystem a bit later. So I'm a professional community builder. I hang out in the open source space quite a bit, particularly cloud native, CNCF. Retired nomad. I actually moved here to Denver about a year ago. Spent 5 years bouncing country to country before that. It was a lot of fun, but at some point you kind of want a real home. And then contributor to open source projects. Cool. And so let's get started with something I'm sure everyone's heard a bajillion times, the shift to cloud. And we're going to talk a bit about how the shift to cloud has affected authorization, right? Because when there was a monolith and everything was kind of contained in one unit, it was very easy to say where your authorization boundaries were, or where to put your policies, right? Once we broke the monolith down into microservices and tools that were interconnected across clouds, right? Now all of a sudden, where those boundaries lie becomes much more difficult to pinpoint. And so not just where to put the policies, but right, just the number of policies that we need, right? Because now we need much more fine-grained control when you have, right, 10 times the number of APIs that your services are hitting, and 10 times the number of users hitting those APIs, and then 10 times the number of components. So now, instead of interacting within one tight sphere inside of one application that's built all together, now you have all of these components. And as your users and your employees interact within the system, you have to be able to understand what is the authorization that is allowed and what policies control that, right? And so when we're very used to loosely coarse-grained authorization, right, where you can say like my network boundaries, everything within it is allowed, and right, maybe you have one group for admin, one group for non-admins, right? Like these very coarse-grained rules don't work as well in this new cloud-native ecosystem. And so I think I've said the word authorization a couple times, and so also known as auth-z, and I kind of want to do a quick explanation here. Auth-n versus auth-z, right? Auth-n, authentication, right? Who a user is, what machine it is, right? Just identifying what that object is, right? That might be JWT tokens, SSO, but really having that identification piece, which is one component or one attribute of your authorization component, right? So, and then on the authorization side, right now we're talking about the actions that identity can perform, right? And so we can get very specific, right? That coarse grain will be your RBAC models, and then more fine grain as you go ABAC, attribute-based access control, and you start to define things based on more granular rule sets of what can and cannot happen, right? Or if you've ever used AWS, you've probably heard of IAM, right? So something similar. And then so now we're talking about the cloud-native stack. Let's talk, what is one policy, right? Like specifically, right, not policy as code in general, but just what is one policy? Right, and one policy might actually be what a specific user, we'll call her Alice, can do or perform, right? Can Alice access an S3 bucket, right? Or can my, right, or on the machine side, like can my CI/CD pipeline deploy directly to production, right? These are all policy questions that you have to answer in some way in, right, plain English before you start defining them in a way that the machines can now comprehend. Right, and so policy always starts with what you're thinking about and how those actions should happen before you can really define them in a code base. And so when we're talking about, when we're talking about policy as code, right, we are talking about having those fine-grained permissions defined in a way that is understandable by machines, right? Understandable by your APIs that are going to talk to it, right? So when we are talking about this, right, having a way that you can write down your policy, check it into a Git repository, and access those policies in a way that's going to protect your system, right? And when you do this, you're going to want to figure out a way to do this that is standardized. You have one framework that's going to work across your systems, right? Because if you have, oh, I have policies here that are defined in this way, and I have policies on the other side of my system that are defined this way, then nothing can talk to each other, right? You're increasing the complexity instead of reducing complexity, which these policies should do. They should reduce the complexity by making it simpler for knowing what should or should be able to happen, right? And when you have this single location, right, we're decoupling those policy and authorization choices from the tools and services that you're using, right? And that decoupling is the key component here, because now, right, with a decoupled policy, you're able to define and enforce these policies in one location, and all of your tools and services can take advantage of it, right? So the decoupling becomes very powerful when you are working across clouds, across system types, across technologies, right? This decoupled motion is what's going to really empower our policy as code motion here. And so let's dive into policy as code a little bit more, and right, let's talk about where do these policies come from, right? I remember at my first job, the policies were all written in a wiki, right? Do you guys remember like logging in, people saying like, oh, on your first day, check the wiki for how you access things, right? But make sure not to break the rules in the wiki. And that was like it. It's just like, okay, they gave me a root account and said, yeah, have fun, don't break the rules. And that was just kind of accepted, right? Like we were all just like, yeah, that's fine, I won't break the rules. And right, like, okay, that worked for that period of time. And then things got more technologically advanced. We started hard coding policies. We started saying like, okay, well, I can dynamically, or not, but I can identify these users a little bit better, and I can understand who they are, so I can build these policies directly into the software that I'm using, right? And then now we are taking that evolution just one step further and saying like, now that I have much more information, just who the user is, but I can understand, right, what machine they're using, what time they're using it, what location they're using it from. We have so much more information now, right, that can help us define and implement these policies, right? And so that's going to give us, that's going to allow us to do this policy as code motion, right, with all of this new information. And so when we're talking about policy as code, I hinted at this earlier, but this graphic kind of helps explain it a little bit better, right? You're going to define this policy in a policy file somewhere, and then your system is going to have a policy engine associated with it, right? If you're using microservices, it might be as a sidecar. If you're using APIs, you might have it running directly on the server itself as like a daemon or something. But that policy engine is going to sit somewhere near that service or tool, and ideally, you're going to want it to be as close as possible. And so what are we getting by making this switch into policy as code, right? When we're switching to policy as code, there should be a reason, right? And the reason is you already know what the software development lifecycle is, but now, right, we've refined that motion over and over and over again. But that same methodologies can now be used for developing your policies, right? And so when you start off in this cycle, the policy development life cycle, right, as I mentioned earlier, right, you're going to be defining those requirements, right? Understanding exactly what should or shouldn't happen, defining those things in plain English so that you can build around them. You're going to start authoring those policies in your policy language, right? Figuring out how to get those down into your Git repositories, right? And now that you're checking in your policies, now you can start doing unit testing, integration testing, right? You can start treating these policies not as I've stood up a new rule and I hope that things work out. I hope I don't cut off, right, a system from the rest of my org. I hope I don't have to go out and restart a switch somewhere because, right, I implemented a policy that is now, disconnected something. I've never done it, I swear. And so, right, being able to deploy now, right, or after having your unit testing, being able to automatically deploy, right, having those best principles in mind and being able to check things in automatically, right, and then once things are out there, being able to monitor things effectively, right, having health checks not just on the system doing the policy enforcement, but the systems that are affected by the policies. Right, and then everyone's favorite, auditing and logging, right, because someone somewhere is going to care eventually, right? And so this is the same life cycle that we have when we're talking about software. Why are we not having the same life cycle when we're talking about policy, right? So now when we are defining policy, we can use those same steps we're already used to develop the language that's going to protect our systems. And so now, kind of the main point of this talk, Open Policy Agent. And so this is a tool that we've been working on for a very long time, much longer than I've been at this company. So it's open source. We've donated it to the CNCF. So it is a graduated project, graduated a couple years ago. And what that means generally is that it has, actually let me ask, is anyone here using Open Policy Agent? Okay, there's a couple. Who here already knows a little bit about Open Policy Agent? A couple more. Okay, cool. Sounds good. And then, so yeah, so for those in the room that have not heard of this, right? So it is a graduated project, which essentially means that it has an adoption, or it has the adoption from the community. It's not just my company that's contributing to this project, right? We have a number of other companies that are helping out and working on the technology and making it a viable open source tool for anyone who wants to do decoupled policy authorization, right? And so very popular, tons of downloads, tons of GitHub stars. We're very active in the Slack community. So if you do want to check it out, you can come and say hi to me in the Slack community. And so a little bit about how it works, right? So I talked about this decoupled motion, or decoupled policy, and this is kind of how it looks in a diagram, right? So we have whatever that tool or service is, right? You can pick your tool of choice, Docker, Kafka, Istio, whatever, right? And then OPA is going to sit now next to that tool or service, and you're going to feed it a decision, right? And so this decision is going to be a JSON construction of information, right? So if it's Terraform, right? Very simply, you're going to take that Terraform plan, you're going to convert the plan into a JSON blob, and you're going to feed it to OPA, and essentially you're going to ask it, does this plan look good, right? Like, are these resources within spec? Are you going to force me to add something to this? Is it missing rules, labels, annotations, right? All the things that you ask people to include whenever they create resources, but somehow they conveniently forget every single time, right? Like, so you're going to start adding those things as guardrails around the deployment so that Terraform now is able to be run and deployed in a way that is safer for everyone to use, right? And so that's going to work with OPA evaluating that plan against the policy that has been defined and maybe any JSON data that you want to give to it, right? And so that JSON data, that might come from an external source. That might be like SSO data. That might be LDAP data. That might be any number of things, right? That might help augment that policy decision. And so, right, it's kind of like a different view of where you can actually put Open Policy Agent, right? It's going to be able to help connect at any point within your application, right? That might be within the deployment section in your CI/CD pipeline. That might be directly in the application itself, doing rules like RBAC and ABAC to define what those users can do, right? It could be within the infrastructure that contains the app, right? Like if you want to know, send something from the front end, speak to the back end, and if so, what sort of data can actually be accessed, right? Or it might just be on the platform itself, defining what sort of resources should my application run on, right? Like you want to make sure that people aren't over-provisioning or oversizing the application, the resources that your application sits on, right? And so some common use cases, I mentioned Terraform. Everyone's familiar with Kubernetes. Envoy as a, like you can do this kind of when from service mesh, one service talking to another, you might want to control what sort of data can pass between them. Very popular is like the custom services, right? This is going to be defining anything that's very particular to what you are doing. There was a good talk by Miro that at KubeCon where they basically created a Go wrapper around a Miro board to live stream decisions. And it was a very cool implementation and very powerful way to process policy decisions very quickly. And so with that, I'm going to get into Rego, which a lot of people who have played with OPA may or may not be a fan of. And so once again, back to this diagram. So we have that policy file, and we have the policy engine. So now, right, we're replacing that with a Rego file and OPA as the policy engine. And so let's write our first Rego policy, right? And so this is kind of, so for any sort of Rego policy, you're going to have three things, right? We showed on the diagram earlier where you have the policy itself, you have the input, and you have the data, right? And so at the bottom here, I'm showing what the data looks like for this, but I'm going to abstract most of it in a second. Right, so the very first thing at the top of this file is a package name, right? And this package name is basically just a logical division between these policies and your other policies, right? So you can name this anything, right? Kubernetes ingress, rback.tests, whatever, right? Like, so this is just a logical division so that you can call policies from one section to another. The next is imports. And so this actually adds a little bit of confusion. I actually get this question a lot, right? Like, I saw a policy that said this, this, and this, but that doesn't work for me. And essentially what we are doing right now is we are trying to preserve backwards compatibility as much as we can until we reach version 1.0. And so with that, all of the new language features that we add, we basically require for those features to be imported, right? So now we have things like contains. And so if you look at the comments here, right, you can see that errors contains if whatever the policy is, right? That's much more understandable for a new person who's coming along to the project than errors brackets, right? Like for a new person, having those expressions defined in English tends to be a much easier way for people to onboard. And if you are writing things, make sure, and you want to use these, you can always check and run things in strict mode. You can do this in our playground, you can do this directly on the CLI, but strict mode will basically force all these things to be true. And defaults, right? So with this language, it is a declarative language. And so if you've written anything for like Terraform HCL, you know that a declarative language, you're specifying intent. And so now we're specifying the intent of what this policy should do and protect. And when you are specifying intent, having undefined variables kind of upsets the system. And so when you say allow is undefined, that will cause you problems down the road as opposed to knowing that it's always going to default to false. This is a very simple solution, but it is something that as you get more and more components in your system, understanding what will happen when your rules evaluate to undefined and making sure that something is there to catch them. And so I'm taking away things at the top, but they're still there, and we're just kind of working our way down this policy. And so we're going to write our first policy, which is one that most people are familiar with, which is admins are allowed to do some action, right? If you're an admin, you should be able to just kind of work with the system in the way that you want. So the rule is allow if user is admin. So allow is the rule head that we want to be true. User is admin is the actual functions that should happen, right? So now underneath this, we're going to define user is admin. And so user is admin if string admin is in data.user roles looking for the user that was provided in the input. And so we can see in the top right corner that Alice was the user that made this request. And Alice is requesting to do a read on object ID 123 for some service type dog, right? And so inside of the actual structured data now, we can look Alice up and see that she has the admin role. So this is going to be true, and she's going to be able to process this read interaction. But what if someone isn't an admin? Right, so if someone is not an admin, right now we need to be a little more granular about what they can and can't do. So now it's allow if, right, some grant in user is granted, So let's pop down, right? We have that user is granted, contains grant if, right? And so now we're going to start looping through this data, right? Some role in user data roles for input.user. So now we're creating these variables. We're looking for a role inside of our data for that user Bob, right? And so we're going to end up with an employee as the role, and we're going to check if that role has the specific grant. And here on the right-hand side, we can see that there are 2 grants here. We have one for read on type dog and one for update on type dog. And so now we go back. We say the input action equals the grant action. And so we can see that Bob is trying to do an update, and Bob has one action that's allowed to do an update, and then the input type, and then the last section here, or the last item in this policy that needs to be right, is input type is grant type, right? So input type is cat, and there's no cat type within the data itself. So with that, we can see that Bob is not allowed to perform this action, right? And so now we've looked at admins and we looked at users, right? And congratulations, right? Like that's your first Rego policy. It's not that hard when you try to keep things very simple, right? Where we end up seeing a lot of confusion is when you try to perform too many things at once. You try to pack in all the data into Rego at the beginning, and you just kind of overload the system, right? And so it makes it very complicated. And so, as I mentioned, kind of full policy development lifecycle. We're just going to do a quick unit test here. So rback.test, right? For any sort of test inside of Rego, you just need to preference it with test underscore, and then you can process these as you are rolling out the test. And with that, we have a mocking function. The mocking function is essentially going to be a replacement for that input that we had earlier. It doesn't always have to be the input, but right, you might want to mock user data, you might want to mock function data, you might want to mock something else. But for the simplest test, you're going to mock input data, right? This is the same one that we saw previously, and so we know that the allow should be equal to true when the input is user Alice action update type cat, right? And so we know from our rule earlier that this is true, right? And so now the opposite test, right? You want to test a positive, you want to test a negative. You want to know that the denies are going to work as well as the allows, right? So now, same functioning, but just adding a not in front of it to negate the allow function, right? So now we're to not allow equals true when input is Bob update cat. So with that, very quick introduction to OPA, Rego, and policy as code. Thank you for listening. And you want to connect, here's my Twitter. And if you want to, we have a bunch of resources for learning Rego and getting started on the Styre website if you want to check it out. Cool. Thank you.
All right. So does anyone have any questions about Rego?
If we want to get started on using OPA, are there any examples or templates that are readily available?
Yeah, so we have a pretty big repository of examples that community members have contributed. So you can take a look at that at just the Open Policy Agent organization in GitHub and kind of just look for, I think it's just called examples. And so there's a bunch of things in there that are very easy to kind of drag and drop and get started today. Mm-hmm. Cool, thank you.
Hey, thanks for the presentation. My team uses OPA, and it's great from evaluating those policies, but one of the challenges we have is we've got a couple of people on the team that are really passionate about it, and a lot of people who don't care about it. I'm wondering if you have any suggestions on how to get like the whole team involved on writing policies and learning Rego.
Yeah, and that's a funny one that we hear quite a bit, and Rego's kind of like that annoyingly smart friend who it's like, you know they're probably right, but just really want them to be quiet because they just keep like iterating and iterating. And so Rego's kind of like that, where you have to figure out a way to work with the tool that kind of makes everyone happy. And so once engineers typically get it, it becomes a very fun tool to use, but it's crossing over that kind of chasm of comfortability. And right, going back to what I mentioned earlier of being able to find the bite-sized and digestible pieces for the newer members of the team, right? Having them jump into a Rego policy code base that's already fully established is much more intimidating than saying, oh, hey, why don't you try to connect this new tool with one small piece, right? And getting them to get that familiarity with the tool so that they get closer to that understanding without having to be overwhelmed with the rest of the things that were already created. Mm-hmm. Thank you for the question.
Cool. All right. Oh, one more.
Last question.
Do you have any examples of security incidents where OPA really helped?
So that's the funny thing about security incidences and tools is that if the tool did its job right, you don't normally hear about it, right? And so from that perspective, right, like it is, we know a lot of the common use cases that OPA is used for, right? And so we know that when you are using it for something like Kubernetes and you want to block a lot of the communication between microservices, or if you want to use it for Terraform and block a lot of the resource creation that might scale up your bill to be a crazy high number, right? We know those are things it can protect, but we never know exactly how many times it's stopped those things, right? We only know what the possibility is for protection as opposed to deflection.
Or can we have examples of things that happened could have been protected with OPA?
Sorry, can you one more time?
Security incidents that happened, in a post-mortem we would have known that this could have been solved by OPA. If OPA existed, this wouldn't have happened.
Nice.
Any situations like that.
Got it. And so yeah, so there are quite a few customers that we have worked with where they've decided to adopt OPA because an incident will occur, someone's hitting their API and something on that API is not fully secured, right? So that API endpoint, maybe it required some sort of authentication, but maybe there's some bypass or some one endpoint out of thousands that was unprotected, right? And so in those cases, right now, right, those processes would have went through unchecked, but now you can introduce OPA and say, oh, now we just want to make sure that we at least have a log of everything, right? Every single API interaction, we want that decision to know why it was granted, right? And maybe for a lot of that, it's that this interaction was granted because we didn't define a policy, right? And when you don't define a policy, that's still a decision that you're actively choosing to do. You're actively choosing to allow those interactions to happen, whether you say yes or no, right? Because you haven't defined anything. And so those are incidences that we're seeing where someone will come in and say like, oh, we realized that there was a hole and we didn't see the holes. And so then they'll implement OPA so that they have that audit transaction record of everything that happens with their APIs.
Thank you.
Cool, thank you.